Lesson 4.4, the laws of logarithms. So you can see we have, this is a big section, lots of information contained in this section. So we're going to evaluate logarithms again. We did this in section 4.3. Remember, evaluate a logarithm means give the value of a logarithmic expression, like what's the value of log base 2 of 16. So we're going to do that again using these laws of logarithms we're going to talk about. But the two biggest topics in section 4.4 are these two: expanding a logarithmic expression and condensing a logarithmic expression using these laws of logarithms. And then we're going to apply those same laws into something called the change of base formula. Okay, so there are three laws. The first one here is called the product property. Product because of this expression right here, x times y. This is a product. So if you're taking the logarithm of a product, then you can expand this expression into two terms using addition. Again, this is called expanding. So we have one logarithmic expression of a product. You can expand that into two terms, both involving a logarithm of the same base. These have a base b. And then the product x times y. Here we have x, and here we have y, both factors of this product, separated by addition. So in terms of how this relates to our lesson, going from here to here is called expanding. But this property works in reverse, not just left to right. If you think of this property from right to left and going in this direction, taking two logarithms and writing it as one, that's called condensing, which is the other part of our lesson, is condensing two logarithmic expressions into a single logarithmic expression. So if you have logarithms of the same base, in this case log base b, and they're separated by a plus sign, you can condense that into one logarithmic expression, forming a product of the terms inside the logarithm. So this is called the product property. Now the next one, called the quotient property. Quotient meaning fraction. So you can see here that we have a logarithm, and the term inside the logarithm is a quotient, x divided by y. If that's the case, you can expand this single logarithm into two separate logarithms of the same base. The numerator's term is always the first term listed here, and then the logarithms are separated by a minus sign. Again, going in this direction is called expanding. Going in this direction is condensing. That's called the quotient property. Now the third one, and this is the final property we'll look at in this lesson, is called the power property. Now we have a logarithm of, and we're taking the logarithm of an exponential term, but the exponential term base does not match the logarithm base. So this logarithm does not cancel the base of this exponential. However, what we can do in terms of condensing or expanding is this exponent can move down in front of the logarithm and become a coefficient, and that's exactly what's happened here. The exponent moves in front of the logarithm and becomes a coefficient, multiplying it here. And that would be an example of expanding. If you take the power and move it down in front, that's called expanding. But then go in the other direction, if you have a coefficient in front of a logarithm, you can move that coefficient back up as an exponent here, and that's called condensing. And those are the three properties we're going to use in our learning target. So the first learning target is evaluate a logarithm. And this is based off the properties we're learning in this lesson, but also some examples from lesson 4.3 of evaluating logarithms. See, the problem is here, for example, 45 is not a power of 3, so I'm not going to be able to write 45 as 3 to some power, meaning log base 3 of 45. Can't evaluate it. Same thing applies to 135. 135 is not a power of 3, and so I can't write 135 as 3 to some power. But if we apply the properties from this lesson, 4.4, I notice that there's a subtract between two logarithms that have the same base. And so we can apply property 2, or law 2, the quotient property, and condense these two logarithms. I can condense these two logarithms into a single logarithm of base 3 using the quotient property. Quotient means fraction. The first term is the numerator. The second term is the denominator. And the key here is that you condense this into one single logarithm. One common mistake I see students make, let me go ahead and erase this. One common mistake I see is students recognizing that this forms a quotient, but forming the quotient incorrectly, meaning this, log base 3 of 135 divided by log base 3 of 45. See, the problem here is this has not been condensed into one single logarithm. I still have two logarithms. The key to condensing is you take two logarithms and you write it as one logarithmic expression. So you take two logarithms, write it as a single logarithm, and the terms inside the logarithm are what form the quotient. 135 divided by 45 is 3. And then applying properties from the previous lesson, 4.3, 3 has a power of 1. And since these now have the same base, log base 3 cancels a base 3. So the answer is 1. Okay, another example. This is also going to illustrate a property 2, the quotient property. So we're taking the logarithm of a quotient. We have a numerator and a denominator, so this is a quotient. So we can expand this single logarithm into two logarithms of the same base, base 5, log base 5 of 1 minus log base 5. And I'm going to change the square root of 125 into 125 to the power of 1/2. One important thing to remember about logarithms is logarithms and square roots don't mix well together. Logarithms and square roots don't mix. You're always best to change square roots into rational exponents. Now, this actually can be a property, the power property, property number 3. These bases here don't match, log base 5 and then 125 to the 1/2. These aren't matching bases, but it has an exponent, so you can take this exponent and move it down to the front of the logarithm. So log base 5 of 1 minus 1/2 log base 5 of 125. Now, something we talked in the previous lesson, in lesson 4.3, log any base, it doesn't matter the base, but in this case log base 5 of 1. Anytime you take a logarithm of 1, that's equal to 0. And then 125 is just 5 to the third power. And since those bases match, the log base 5 is going to cancel base 5 there, leaving 3. So this is 0 minus 1/2 times 3, which is negative 3/2. So those are examples of using these three properties, product, quotient, or power property, to evaluate a logarithm. Okay. Now our second learning target here is expanding logarithmic expressions. This technique is not hard to do. However, it's a technique, or it's something that you'll use more commonly in a calculus course. What we're learning here is just the skills and the technique. The application of this technique, expanding a logarithmic expression, you probably won't use much in Math 1050. You'll use it much more if you are taking a calculus course. But that's one of the purposes of Math 1050, is to give you the skills and to prepare you for a calculus course. So, like I said, expanding logarithmic expressions is not that hard to do. We're using one of the, or sometimes several of the three properties, the product, the quotient, or the power property. This one here, 8 times x, is a product. So since we're taking the logarithm of a product, we can expand that into two logarithms of the same base, base 2. So this would be log base 2 of 8, and the product property says to expand using addition, so plus log base 2 of x. And oftentimes you would be done here. This would be the final step. However, this particular one, log base 2 of 8, this one can simplify down a little bit more. Log base 2 of 8 is log base 2 of 2 cubed. So then the log base 2 is going to cancel the base 2, leaving 3 plus log base 2 of x. So if you can simplify and evaluate the logarithm, you are expected to do that. So this would be the final form of the answer here for part A. Okay, part B. Again, we have a product here, x times y squared. And so the product property is going to apply when we expand this into several logarithms. We're going to use the same base, log base 3 of x plus log base 3 of y squared. Now we don't have any numerical values. These are algebraic expressions involving variables, so we don't need to evaluate a logarithm. However, we do have an exponent, and so we need to use now property 3, the power property, and this exponent is going to move in front of this logarithm as a coefficient. So you'd write it as log base 3x plus 2 times log base 3 of y. And that would be the final form of that answer. Okay, part C, here we have a quotient, and so we can apply the quotient property and expand this into two logarithms or two logarithmic expressions using subtraction. So what we'll see here is log, and there's no base written, this because this is a common log, it's log base 10, so it's log x squared minus log of y, and again we have an exponent here, and so applying the power property now, this exponent is going to move down in front of that logarithm and become 2 times log of x minus log y. Okay, part D. We have a quotient because we have a numerator and a denominator, but our numerator also has a product. And so we're going to have to apply both the quotient property because we have a numerator and a denominator, but also the product property because we have a product here. But overall, this is a quotient. So the first expansion we're going to do is expanding the quotient using subtraction. So we're going to have log base 4 of the numerator, xy squared, minus log base 4 of the denominator, z cubed. Now we can expand this product using the product property, which is addition, so we can expand this logarithm into two more logarithms using addition. So log base 4 of x plus log base 4 y squared minus log base 4 z cubed. And then finally we can apply the power property and move this exponent in front of that logarithm as a coefficient and move this exponent down in front of that logarithm as a coefficient. And that would be the final form of that. Okay, now our next learning target in this lesson is reversing this process. It's called condensing. That's where you would take, for example, this several logarithmic expressions, and you have to make sure they all have the same base, but if you have several logarithmic expressions, you can work your way backwards through this process, condensing until you end up with a single logarithmic expression, like that. And this, the application of this technique we will use in this course. This is helpful when we're solving logarithmic equations. See, it's very, very difficult to solve an equation that involves several logarithms. However, if we can condense that into one single logarithm, then solving the equation is going to be much, much easier. Okay. So first thing we notice is these two logarithms have the same base, and they're separated by a plus sign. So this is going to be an application of the product property. We do also notice that there are coefficients in front of the logarithm. These coefficients can be moved back up and condensed as a power or an exponent. So that's actually the first thing I'm going to do, is move the coefficients back up as an exponent. Now since we have a plus sign between these two logarithms, the two logarithms can be condensed into one single logarithm, and then the terms inside of those logarithms are going to form a product. So that would be the final form there, log, and it's log base 10, it's a common logarithm, log base 10 of x squared times y to the fourth. Okay, part B. There's a subtraction between two logarithms that have the same base, log base 2, separated by subtraction, which means this is going to be a quotient property. So when we condense this, we're going to end up with a quotient or a fraction. Now I notice there's a 3 in front of this logarithm, so this 3 can move in front, not in front, this 3 can move up top rather as an exponent. Now this over here is being divided by 2, and this quite often is confusing to students until you see it once or twice and then you recognize the trick here. So let me show you what you can do. Rather than dividing by 2, I'm going to move this divide by 2 in front as a coefficient of 1/2 times log base 2 of x So far I haven't applied any logarithm properties. I've just used properties of arithmetic. Dividing by 2 is the same thing as multiplying by 1/2. Now the reason I'd want to multiply it by 1/2 is now this is the power property. I have a coefficient of 1/2, which means I can move that 1/2 up to the top as an exponent of x and write it as log base 2 of x to the 1/2 minus log base 2 of y cubed. And now that there's no coefficients in front of the logarithms, we can condense. The two logarithms can be condensed into one single logarithm, base 2. And now since it's separated by a minus sign here, there's a minus sign, which means we're going to have a quotient. This is my numerator, this is my denominator. So x to 1/2 divided by y cubed. And that would be the final form of the answer. Now, your textbook may write this instead of x to the 1/2. It may be written as the square root of x, because remember, x to the 1/2 is the same as the square root of x. The textbook may write it that way, but I don't require that you write it that way. You can keep it as x to the 1/2. Now, part C, we have multiple logarithms beyond just 2, so we have obviously 3. So the way you want to approach this is starting at the left, take the two logarithms at the leftmost part of the expression and condense those two into one logarithm, and then take that, condense it with this one. First things first though, you take the coefficients and move them up as exponents. So log base 3 of x plus log base 3 of y to the 4th minus log base 3 of z squared. So now I'm going to take just these two logarithms here and condense those, and since they're separated by a plus sign, then it's going to be the product property. So log base 3 of the product x times y to the 4th minus log base 3 of z cubed. And I'm going to take and condense those two logarithms into one single logarithm, log base 3. And since they're separated by a minus sign, I'm going to form a quotient, meaning fraction, where this is my numerator, xy to the 4th is my numerator, and z cubed is my denominator. And that would be the final version of that answer, or of that problem. Okay, the last learning target is called the change of base formula. And this is actually quite helpful in any course, a Math 1050 course, a calculus course. See, if you recall, in lesson 4.3, the calculator, a scientific or a graphing calculator, does have logarithm capabilities. You can evaluate logarithms, but only two specific logarithms. You can only evaluate log base 10, the common log, or log base e, or the natural log. Those are the only two logarithms that a calculator can evaluate. And so if, for example, we needed to evaluate log base 2 of 5, log base 2 of 5, 5 is not a power of 2, so I can't write 5 as 2 to any power. So this we wouldn't be able to evaluate by hand using any of the techniques that we've learned so far. And we couldn't also do this on a calculator because a calculator cannot evaluate log base 2, so we would have no way of finding the value of log base 2 of 5 without this change of base formula. So let me show you where it comes from. So let's suppose log base b of x is equal to some value, and let's say that it's equal to y. If I want to rewrite this expression in exponential form using a technique from the previous lesson, 4.3, remember that in exponential form, if you use a base of b here and a base of b here, this would be written as b to the power of y is equal to x. Now, I'm still trying to figure out what the value of y is, because I know that log base b of x has a certain numerical value, and that was equal to y. So I still want to be able to solve for y in this exponential equation. But I want to use logarithms that I can evaluate on a calculator. I want to use either common log or natural log. Now I'm going to use common log on both sides of the equation. Now, one of the things that we learned in this lesson, 4.4, is if you have a logarithm of one base, but an exponential of another base, if the bases don't match, they're not going to cancel, but you can take the power and move it down in front as a coefficient. So I can take that y and move it in front as a coefficient. And now I can isolate this y. Since y is multiplying log base b, I can reverse multiply using division and divide by log of b on both sides. And now I have the value of y, because that cancels. So the value of y is log x divided by log b. And that is the change of base formula. Here, let me write it a little more cleanly. If you have log base b of x, you can change that into common log now of x divided by common log of b. And that may not seem very significant, but going back to the example we were looking at, log base 2 of 5, this was not something that we could do on a calculator, nor was it something that we could evaluate by hand. But applying this change of base formula, log base 2 of 5 becomes common log of 5 divided by common log of 2. And this is something now that can be evaluated on a calculator. Log 5 can be evaluated on a calculator, and then you can divide that by log 2 on a calculator. And that's approximately 2.32 if you were to do this on a calculator. So again, another one here to practice. Log base 8 of 5. This is not something that can be evaluated by hand because 5 is not a power of 8, and calculators cannot handle log base 8. So you would apply the change of base formula, which is log 5 divided by log 8. And incidentally, just by way of information, this property also works with natural log. So you could also use natural log 5 divided by natural log 8. Either one of these is going to give you the exact same answer. And both of those logarithms can be used on a calculator. If you were to type this into your calculator, you'd get approximately 0.774. And that is the final learning target for this lesson, lesson 4.4. So we have just finished up with the change of base formula. This is helpful to evaluate logarithms that cannot be evaluated by hand. Here we are condensing logarithmic expressions, which is helpful in solving equations. Okay, this learning target was expanding logarithmic expressions. This technique is helpful, more helpful if we're doing calculus. So you may not see a lot of this applied in a Math 1050 course, expanding. We also used these properties to evaluate logarithms. And that should do it.